Hello students, welcome to the session 2 of the chapter number system. In the previous class, we discussed about many different numbers like natural numbers, whole numbers, integers and rational numbers, and we thought all these are real numbers. Well, up to 500 before Christ era, it was believed that rational numbers are the last of numbers or end of numbers. But by this 400 BC era, again it is observed that there exists another set of numbers which are not coming under rational number. So in such case, so how those numbers exist, how they came, it has to be learned. So today we'll discuss about the more of these real numbers. The numbers which can be presented in real number line are called as real numbers. We have observed that in real numbers, natural numbers are there, whole numbers are there, integers are there, then rational numbers are there. Then except rational number, such more numbers are also there which we have still not learned. So as we know already, the numbers which can be presented in P by Q form, they are called as rational numbers. So now we'll discuss about the numbers which cannot be presented in P by Q form, what they will be called. So they will be called now as irrational numbers. So in irrational numbers, how it can be presented, how it has to be written. So let us see. As we know, all the real numbers we can represent in decimal numbers. So let us start this classification of decimal numbers. Then we will learn. Let us come to here. So if I'll write decimal numbers, actually these numbers are the real numbers. These decimal numbers I can split into two parts. First part I can write is a terminating decimal. I can write it is a terminating decimal. Terminating decimal, the decimal numbers which are terminating after some places of the decimal parts. Then other part is non-terminating. These are non-terminating. So what are terminating decimals? For example, I can give it here. Terminating decimals are 1.2. So after decimal one place, it is terminated. It is no more continuing. I can write 2.32. So after decimal two places, it is terminated. Such type of numbers are called as terminating decimal numbers. Now come to non-terminating decimal numbers. How these numbers behave? So these numbers are again classified into two parts. First part, we can say it is recurring or repeating. Recurring non-terminating decimal numbers. And the other part is non-recurring. Non-recurring non-terminating decimal numbers. What are the recurring decimal numbers? Let us see. If I write 1.3 3 and so on, that means 3 is continuing. In such case, I will tell it is a recurring number. So after decimal places, it is extended indefinitely, but one number, one digit is repeating. So one more such example I can give it is suppose 2.25 and so on. That means this 25 is continuing. I can say these types of numbers are recurring non-terminating decimal numbers. But there exist some decimal numbers which are not terminating as well as not recurring also. For example, let me write one example. 1.01, 0001 and so on. In such case, you will find though it is not terminated at any place, it is extended, but none of these parts of this type number is recurring. So here I find a pattern of numbers. So it is 01, it is 001, it is 0001. I cannot give any particular part of this number is repeating. It is coming in patterns. So it will not be considered as repeating. So such type of numbers are non-recurring numbers. Now these terminating decimals, what we learned, they are coming under rational numbers. As we have already learned, the rational numbers is denoted with the set The set of rational numbers denoted by the letter Q. So this terminating decimal numbers coming under the rational numbers, and we denote it as Q. Now come to non-terminating decimal numbers. They are classified into two parts: recurring, non-terminating decimal numbers. These recurring non-terminating decimal numbers, they are also coming under this Q. They are also called as rational numbers. But those who are non-terminating, non-recurring decimal numbers, they are called as irrational numbers and denoted by Q dash. This is called Q dash. The set of all rational numbers represented as Q and the set of all real numbers which are not rational are represented as Q dash. So Q dash is the set of all decimals other than Q. So let us see how this non-terminating, non-decimal, non-recurring decimal numbers exist. Okay, let me rub it. These irrational numbers we can write in three different ways. These irrational numbers we can write in three different ways. For example, we can write these irrational numbers first in decimal expression. I can write in decimal expression, decimal numbers, or I can write in real algebraic expressions. It is called real algebraic expression. I will show the example how it is real algebraic expressions, real algebraic numbers or expressions. Or sometimes it is called as transcendental or symbolic forms. For example, I can write it as pi, I can write e. These are the transcendental numbers. So these are some examples. We are very often you are using this terms pi. This pi is an irrational number. So now what are the decimal numbers we have seen? Some decimal numbers 1.12, 112, 1112 and so on. These type of numbers we can write it as irrational numbers. So similarly, real algebraic form numbers, they are written as √2, then √3. Such type of numbers are real algebraic numbers, and these are transcendental numbers or written as symbolic form pi, e, like this. So these are all about the irrational numbers. Now all these decimal numbers what we read or the real numbers what we read, how this can be presented in decimal form. For example, these are all irrational numbers. Let me now we'll discuss about the how real numbers can be converted into decimal form. We'll go to the real numbers converted into decimal form. Let us come to here. Real numbers are broadly we classified as rational and irrational. We can say rational and irrational form. Rational and irrational. This is a rational and irrational. This is rational when I find it is always written in form P by Q. So when it is written in P by Q form, so I can say P by Q, what this Q can be. For example, let me write it here. Suppose I will write 1 by 2. So 1 by 2 I can write in decimal form. How I will write it in decimal form? For converting into decimal, I will use many different ways. For example, actually I can divide this 1 by 2. In a long division process, I can divide this 1 by 2 and I will find it is coming 0.5. It is coming 0.5. But if I change it to 1 by 8, again I have to think how I have to divide. So if I divide, go on dividing a real long division process, I will find it is 0.125. Now similarly, if I write it here, I will have 2 by 15. Now in such case, how to find this number? So I have to go for dividing. Let me divide it here. We'll observe. So 2 is the dividend and 15 is the divisor. Let me divide now. I will put the decimal number here because it is less than that. So I will put the decimal number first. Then after that it becomes 20. I will put 1 at here. It will become 15. So 5 will carry it here. So as the decimal it will give 0. So now I will put it here 3. So 15, 3 is a 45. Now 5 comes here. Again due to decimal, again it will come. So again I will put 3. So this will give 45 again. So the 5 again here. Now if I give again 0, I will find again 3. So this will continue. So I will find this 2 by 15 comes as 0.133 and so on. That means I can tell it is 0.13 bar. This bar notation is given to represent the repeating parts of the decimal number. Here 0.1333 and so on is written as 0.13 bar. Bar is given on 3. Now, as 2 by 15 becomes now 0.13 bar, if I'll instead of 2 by 15 it will be 3 by 15, what will be the result? If I'll tell it is 3 by 15, what will be the result then? If it will be 3 by 15, this can be minimized and you will find it is 1 by 5. And 1 by 5 you will go on dividing, you will find it is 0.2. Now this is a terminating decimal, but here in 2 by 15 it's a non-terminating decimal. So what basic difference we find in between these two fractions or rational numbers, that one is giving terminating decimal while other is giving non-terminating decimal. Let us observe some more examples. 13 by 40. In a rational expression 13 by 40, we find the denominator is 40, which can be splitted into its prime factors as 2 to the power 3 into 5. As I have seen at here 2 to the power 3 and here 5 to the power 1 is there, to make it both the powers 3, I multiplied 5 to the power 2 in the denominator. To make it equivalent, I also multiplied 5 to the power 2 in the numerator. So the numerator became now 325 and the denominator becomes 2 into 5 whole to the power 3. So it is expressed now 325 divided by 1000 and in decimal form it becomes now 0.325. In another example, we find it is 19 by 2500. So 2500 in denominators can be splitted as 2 to the power 2 into 5 to the power 4. So as both there are two factors 2 and 5, but both of them do not have the same power. So in order to make their power same, so I multiply 2 to the power 2 in both denominator as well as in the numerator also. So in the numerator I find it is 76 and the denominator becomes now 2 to the power 4 into 5 to the power 4. Then 76 by 2 into 5 whole to the power 4, that becomes now 76 by 10,000 and finally it becomes 0.0076. In another example, we'll find 11 by 30 is equal to 11 by 30 splitted as 2 into 3 into 5. Here 2 to the power 1 into 5 to the power 1 and another 3 is there whose power is also 1. Now 2 into 5 multiplied together it becomes 10, but still another 3 is existing in the denominator. So that's why in this case we are not finding the decimal as a terminating. So we find it is 0.366 and so on. That means it is continuing. From the above examples, we observe that in the standard form of a rational number, if the denominator is in the form of 2 to the power m or 5 to the power n or 2 to the power m into 5 to the power n, where m and n are non-negative integers, it can be expressed as terminating decimals, otherwise it is non-terminating recurring decimal. Now what we learned, all these real numbers, what we have seen, suppose this is a real number set. This entire becomes now real number set. Now in this real number set, we have seen this part up to this much is the rational numbers. This is the rational numbers and this part is the irrational numbers. This implies that how many rational numbers are there, as we have taken the infinitely many rational numbers are there. So similarly infinitely many irrational numbers are also there. Like infinitely many rational numbers, infinitely many irrational numbers also there. Then from this rational numbers we have already covered, we can say some portion of them are integers. Let us take this portion of these are integers. Out of these integers, some portion of them are whole numbers. I can say this portion is whole numbers. Again, out of this whole number, some portions are natural numbers. So I can say it is natural numbers. So I can write it is n, then this will be w, this will be z, this will be q. and this is Q dash. And this together entire set is now R, or real number set. Okay, so these real numbers we have learned. These real numbers are combination of all the rational and irrational numbers. So then we'll move to the next part. When we cover this rational numbers, how to find the decimal number of these rational numbers. Okay, for example, let me rub it. The decimal conversion of irrational numbers. We have seen the decimal conversion of rational numbers. Now we'll see the decimal conversion of irrational numbers. As we know, we have learned that here root 2 is a real algebraic form. So how to find this root 2 is a irrational number. Now if you go on finding the value of root 2, you will find it's a non-terminating, non-repeating decimal number, or non-terminating, non-recurring decimal numbers. So if I'll go on finding, I will find its value by square root method. I will find its value will be 1.4142 like this. Okay. Then if you will find it is root 3, similarly you will find it is 1.732 and so on up to. Okay. So between this root 2 and root 3, if I suppose to find such more irrational numbers has to be put in between. This is the irrational number. This is also an irrational number. But between these irrational numbers, I have to find some more irrational numbers. So how will I find then? So I have to find a number which is more than this root 2 but less than the root 3. So I have to find again. Here it will be 1. So when I have to see this number 1.41 and here it is 1.73. So I have to take one more number which will be more than 1.41. So I will take it 1.5. Then I have to create such a number which will not be repeated. So I will write 1.52, 552, 5552 and so on. In writing such pattern of this number, it will be confirmed that even if it is extended, at no place we will find none of these parts is repeating. So such type of number gives us a clear idea about the irrational numbers. I can find this number lies between the root 2 and root 3 also. I can create many more numbers like this. Suppose I will write it as 53 and 553, 5553 and so on. So you can also create a lots of numbers which lies between any two given irrational numbers. Okay, so how to convert this numbers, decimal conversion of these irrational numbers, now we learned. Let us go to an example of irrational numbers and rational numbers. For example, now it is given, one question is given, insert two irrational numbers. Insert two irrational numbers between 3 and 5. Suppose this 3 and 5, these are rational numbers. And we have to find two irrational numbers between this 3 and 5. Very easily we can find. How will find it? Now we have to find the value of the irrational number which will be more than 3. As we have already learned, we can express the decimal number, irrational number in decimal form. So I can write the required numbers are, now I will write 3.41, 441, 4441 and so on, and 4.52, 552, 5552 and so on. Look at these numbers, now they lie within this 3 and 5 and they are the irrational numbers. Similarly, now let us go to the next part. How to find the rational conversion of a decimal number. The number which is already given in decimal form, we have to convert into rational numbers. So how it will be done? So when it is there, so these decimals we have already learnt. It is of two types. One is terminating, other is non-terminating. Now terminating decimal numbers, the terminating decimal numbers, this terminating decimal numbers we can convert into rational form. Those are non-terminating and recurring. Non-terminating and recurring, they can be also converted into rational form. But those who are non-terminating, non-recurring, they cannot be converted into rational form. So what we can do now, let us get a terminating decimal number. For example, it is 1.2. So how to convert this 1.2 into decimal form? Very simple. We can write it as 1.2. 1.2 as 1, 2 by 10. Simply, I can write it as 12 by 10 and I will write it as 6 by 5. So this is the value. When I reduce this by 2 and reduce this by 2, I will get it is 6 by 5. So 6 by 5, I got it is 1.2. Now, suppose this is not terminating, it is a non-terminating recurring number. For example, I have to write suppose it is 1.27 and so on. Now here we find it's not terminating, it's a non-terminating, but it is repeating. So such type of numbers I can write it is 1.27 bar. So how to convert such type of numbers into rational number? So let me take this number, entire number, I will take it as x. So I will write it here now, x equal to 1.27 and so on. Now how many numbers are repeated? Here you will find these 2 digits are repeated after this decimal part. So to bring this 2 digits on the left hand side, I have to multiply 100 with this x. So I can write it here now, 100x equal to 100x. If I will multiply x equal to 1.27 bar, so when 100x I will multiply, so I will find it is 127.27 and so on. Now if I compare between this x and 100x, the after decimal portion of both the numbers are equal. So if we will subtract this x from this 100x, we will find this after decimal portion numbers, they will be cancelling. So what is left now? So if you subtract 100x minus x, you will find it is 99x and this will be 127 minus 1. So the difference of this integral part, it will be 126. And 99x equal to 126, so x will be how much? It will be 126 by 99. So now we can minimize this by cancelling by 3. Let us write it as 4 and it is 2. Now this will be 33. And again it can be cancelled by 3. So you will write it as 14. This will be 14 divided by 11. So this will be your result. So now what we have written 1.27 bar, when it is represented as rational form, we find it is 14 by 11. So how this number is converted into this rational form, we have learnt it here. Okay. Similarly, we can go for one more example. Let me write it here. Suppose I will write it is another number I will take. Convert 0.235, where bar is on 35, that means 35 is repeating. In such case, into P by Q form or rational form. So convert this 0.235, where 35 is in repeating form, into P by Q form or into rational form. So how it will be converted? Let us see again. Let us declare x equal to 0.235, where 35 is in repeating. So I can write 35, 35, 35 and so on. That means 35 is continuing. Now how many digits after this decimal portions are not repeated? You can observe there is only one place, that is 2, which is not repeated after this decimal part. So in such case, we can bring this 2 to this side by multiplying 10 to this x. When I multiply 10 to this x, I will find it is 2.353535 and so on. Yes or no? Then how many digits are repeated? In the first term, I will find how many digits are repeated. This 353535, there's 2 digits are repeated every time. So let us bring these two terms, these two digits this side by multiplying more 100 to it. You will find it is, so when 10x is equal to 2.3535 bar, so you will multiply more 100 it. So 100 multiplying to 10x, it becomes now 1000x. Now 1000x equal to how much? It will be 235 point. So decimal will be moved to that place. So it will be 35, 35, 35 and so on. Then I will observe this between this 10x and this 1000x. In these two numbers, this after decimal portions are same. So if I am subtracting this 10x from this 1000x, I will find the after decimal portions will be cancelling. So here, if we subtract this 0.353535, they will be cancelled. So remaining is only the difference of the integral numbers. That is 1000x I am subtracting 10x. So 235 minus 2, this becomes now 233. And this will be 990x. Now I will find 990x equal to 233. So now 990x equal to 233. So x will be equal to how much? 233 divided by 990. Okay. So now we can make it simple form, or you will write it here. This x equal to now 233 divided by 990. So if it will be cancelled by any factor, you will do, otherwise this will be the rational form. Okay. So this number we find it is 0.235, where 35 is in repeating form. When it is expressed in rational form, it becomes 233 by 990. Okay. Understood now? So we learned today what is the terminating decimal number, what is the non-terminating decimal number. What is the non-terminating decimal numbers are again classified into two types: non-terminating recurring, non-terminating non-recurring. When non-terminating recurrings are coming under this rational numbers, when non-terminating non-recurrings are coming under irrational numbers. Okay, and irrational numbers and rational numbers, both the numbers how to convert into decimal form and decimal numbers into rational form, both the things we have discussed. Okay, so let us go for some questions. I will give some questions, practice question to you. Okay, so let us learn how to convert some more numbers into rational form. Okay. For example, let me give some questions now. 0.6. How to convert this number into rational form? 0.6 is a simple terminating decimal number. When simple terminating decimal number, how to convert? Simply we can write it is 6 by 10. And 6 by 10 can be written in minimum form. So it will be write it is 3 by 5. So 0.6 is converted. Now next we'll discuss about 0.4777 and so on. Here it is a non-terminating decimal number. Non-terminating but repeating. So how to convert the such numbers into? Again you will write. For that we have to use some process for that. So we will take now, let x equal to 0.4777 and so on. Now how many digits are repeated? How many digits are not repeated on the other side? So it is 4. Only one digit is not repeated. So let me multiply 10. So when I multiply 10, so I find it is 10x equal to 4.777 and so on. Now I find again one digit is there on the other side which is repeated. So to bring this number which is repeated, I have to bring it here. So I will multiply more 10 to here. It will become now 100x. So I will find it is 47.777 and so on. Now I will find this after decimal portion of both the numbers are equal. So I can subtract now. So 100x minus 10x, I will find it is 90x equal to, these portions are cancelled, so 47 minus 4, this will be 43. And 90x equal to 43 implies x equal to 43 by 90. So this is your required rational number of 0.477 Okay, if this is the bit 1, so this is your second bit. Let us go to the next one question, bit 3. So let me rub this first bit. I will let it is here. Now bit 3, 1.234. Here bar is on 4. That means this 4 is repeating and 2 places are not repeating. So how to find this? I will again declare let x equal to 1.23444 and so on. How many digits are not repeated? On the other side, 2 digits are not repeated. So I will find, to bring these 2 digits to this side, I have to multiply 100. So 100x equal to how much? It will be 123.444 and so on. Now this 4 is repeated every time. This single digit 4 is repeated. So to bring this 4 to this side, I have to multiply more 10 to this 100x. So this will become now 1000x. And 1000x equal to how much? 1000x will become 1234 and so on. Now I will subtract this 100x from 1000x. I will find it is 900x. And this 900x equal to, this after decimal portions will be cancelled. So now difference of these two integral numbers only will the answer. 4 minus 3 is 1. 3 minus 2 is 1. 2 minus 1 is 1. And here it is 1. So this equal to 900x equal to 1111. Now x equal to how much? It will be 1111 by 900. So this will be your answer. This is your x. Okay. So let us recapitulate what we discussed today. We discussed today that about the real numbers are broadly classified into two basic categories. One is rational and other is irrational. Rational numbers are further classified into integers and integers into whole numbers and whole numbers into natural numbers. But irrational numbers are further not classified. But irrational numbers can be presented in three different forms. One is in decimal form, one is in real algebraic form like root 2, root 3, such type of numbers. And one more form is a transcendental form, or it is symbolic form, we can say. It is pi. Pi is very famous. We know it is the value of pi is 3.14 we are writing. Sometimes we also use pi as 22 by 7. This is a misconception in the student's mind. They use this pi as 22 by 7. Pi can be considered approximately as 22 by 7. But pi and 22 by 7, they are totally different. Pi is an irrational number and 22 by 7 is a rational number. 22 by 7 is expressed in form of p by q, but pi cannot be expressed in p by q form because it's a pure irrational number. So, but both of them can be considered up to decimal. Some places they are equal. That's why for calculating purpose, we are considering pi as a 22 by 7. In some places we consider pi as 22 by 7, but it doesn't mean pi equal to 22 by 7. So such type of pi and these are the irrational numbers in symbolic forms. Now we learnt then how to convert these real numbers into decimal form. So when we convert real numbers into decimal form, we find there are two forms. One, when it is terminating, other it is non-terminating. When it is terminating, we have to find the denominator of this p by q form must be in the form of 2 to the power m or 5 to the power n or 2 to the power of m into 5 to the power n. If except this 2 to the power of m into 5 to the power n, any other factor exists in the standard form of this p by q, then you will find such type of numbers will expressed in non-terminating decimal numbers. That we discussed. Then again, how if it is given in decimal form, decimal numbers, how to convert into rational form, p by q form. We discussed up to such examples we have taken and we concluded up to this much. Okay, so in next class, we'll learn about how to represent these irrational numbers in the number line. Okay, so that's all for today. Thank you.